Video 2-4, Dimensional Analysis, Derived Units, and Problem Solving Strategies. So, first thing we'll look at, dimensional analysis. This is an important skill. Again, make sure you understand it, and it's really simple. If you have problems, make sure you get help during class. So, what's dimensional analysis used for? Okay, this basically used for converting one system of measurements to different systems of measurements, different units. Units are the important things here. Okay, so to do this, what do? Write out the given quantity, and the important thing is the units. Always multiply it by something. Okay, put the units in first before you put in numbers. What units go on the bottom? The units that you're getting rid of, which have to be the same as the units you're starting with. On the top, put in the new units that you want. Okay. Now we got to put in a couple numbers. What number goes up here? What number goes up here? Okay. Well, once you figure that out, this is really simple, and that's it. The problem's done. Okay. The units on the bottom will cancel out the units on the top since they're the same. So where do these numbers come from? Okay. This whole fraction here is known as a conversion factor. What's a conversion factor? It's simply a fraction that's equal to 1. How do you make a fraction equal to 1? Make the numerator equivalent to the denominator. Okay. How do we do that? You use equalities. So, some common equalities. 1 foot equals 12 inches, 1 hour equals 3,600 seconds, etc. Okay. So, in other words, I can use as a conversion factor, I can put feet on top, inches on the bottom, and make sure the top is equal to the bottom. 1 foot is equal to 12 inches. Or I could also say inches on top, feet on the bottom. Make sure it's still the same equality. 12 inches is equal to 1 foot. Why would I use it this way? Why would I use it that way? Well, again, depends on what units you were starting with. If we were starting with inches, we'd use this one because inches on the bottom would cancel out with the inches that you're given. If I were starting with feet, I would use this equality because then the feet would cancel out with feet. Okay. Now, in terms of sig figs, because we define these equalities, we're saying we take exactly 1 foot and it's equal to exactly 12 inches. Take exactly 1 hour, it's exactly 3,600. These numbers right here are all defined as exact quantities. When you write an exact number, it is 1.000 infinite number of zeros, or 1,000.000 infinite number of zeros. So these have infinite numbers of sig figs. This number right here is the only one that's not an exact quantity. 1 kilogram is around 2.205 something pounds. So this one right here only has 4 sig figs in it. Okay, that's important when you're putting these things into your problems and trying to figure out sig figs. Okay, so try a simple one. How many pounds are in 9.8 kilograms? Okay, so simple, start out with our given quantity. That's the first thing we write out, 9.8 kilograms times something over something. Okay, next thing, put in the units. Okay, on the bottom we have to put in kilograms, so it'll cancel out with the kilograms that you're starting with here. The units we're going to are pounds, those go on top. Okay, plug in your equality. We noticed from the first page before this, 2.20 pounds is equal to 1 kilogram. Okay, cancel out the units. Only thing that's left over is pounds. Okay, 21.602 pounds. Now, this number is an exact number, so that has an infinite number of sig figs. This we said only had 4 sig figs. This number here, 2 sig figs. So your answer has to have, according to the multiplication division rule, the one with the least number of sig figs, so it should only have 2 sig figs. Okay. 1 inch is equivalent to 2.54 centimeters. How many inches are in 2.50 meters? Okay, so take a look. Equivalent, that means equals. So that's actually an equality that we have. 1 inch is equal to 2.54 centimeters. Don't use these numbers as your starting quantities. Okay, we want to start out with 2.50 meters times something over something. Okay, I want meters on the bottom. Ideally, I would like to change it into inches. Okay, but we don't have an equality between meters and inches. Okay, so what do? Instead of going to meters, I go to centimeters. Now, this equality isn't written down, but you should know it. 1 meter is equal to 100 centimeters. Okay, cancel out the units. We will now have the units of centimeters. That's not what we want. We want inches. So you can go forward and do multiple steps. Okay, keep going until you get the units that you want. So on the bottom, I have centimeters. I got to get rid of centimeters. Okay, on the top, I want inches. Now use the equality we just got from the problem. 2.54 centimeters equals 1 inch. Okay, cancel out. Now the units when we're done are going to be inches. So there's our answer. Round it off in terms of sig figs, and you should only have 3 sig figs. Okay, now derived units. We can build on the idea from what we just learned in dimensional analysis. Okay, derived units are units that are obtained by multiplying or dividing standard units. So in other words, the standard unit for volume is actually length times width times height. If you measure length in meters, width in meters, height in meters, that means it's in meters cubed. Okay, now how do you find equivalent units? Well, what if I said go change 200 cubic centimeters into cubic meters? Okay, can you just simply do the kids have dropped over dead converting metrics thing and just say, oh, I'm going from meters, which is right here, to centimeters, and just move it that way and just say, oh, all I have to do was whoops, we're going the opposite. We're from centimeters, move that way, and just move the decimal place 2 to the left. Okay, that does not work. So you know this equality, 1 meter equals 100 centimeters. How do I get from cubic to cubic, though? Well, I need an equality. Okay, now, if you cube the left side, you cube the right side, you come out with meters cubed and centimeters cubed. Cube 1, you get 1. Cube 100, you get 1 million. Okay, so this is your equality. 1 cubic meter is 1 times 10 to the 6th cubic centimeters. That is what you'd have to do. So we could do dimensional analysis, say 200 cubic centimeters times cubic centimeters on the bottom, cubic meters on the top, and your numbers, 1 cubic centimeter, 1 times 10 to the 6th. Okay. How many square feet are equivalent to a square meter? 1 meter is 3.28 feet. Okay. Well, let's set this up. How many square feet equivalent to a square meter? So I am starting with 1 square meter, and I want to figure out how many feet squared I have. Okay, so I needed to do some dimensional analysis. 1 meter squared times meters on the bottom, square feet on the top. I need an equality. Well, here's our equality, but it's not the correct units. So if I square the left side and square the right side, okay, I will get 1 meter there. And on the top, I'm going to need 3.28 squared. Okay, and you can plug that into your calculator and figure out what you get. Okay, now, problem-solving strategies. Okay, problems facing you in this class are going to fall into 1 or 2 categories. They're either just simply going to be dimensional analysis, which is basically conversion. Okay, or they might involve a formula. Okay, in other words, if I say, here's the density of an object, here's the mass of the object, figure out what the volume is going to be. Okay, that means you'd have to solve for volume using this whole formula right here. Okay, often you're going to have to do both things. So what do you do? First of all, still follow this step right here. Okay, is it simply conversion? Is it a formula? If it's a formula, do you have the right units? Okay, So if you have to use a formula, figure out which formula you need to use and rearrange it to solve for the unknown. In other words, if you're solving for volume, don't plug numbers in here and here and then try and solve for that. Okay. Rearrange the formula. So volume would be equal to mass over density. Okay. Remember the little trick about switching diagonals. Okay. Now you can plug the numbers in there and calculate. Okay. Second thing, convert any given quantities into the proper units if necessary. So if the mass was given to you in kilograms, but the density was given to you in grams per cubic centimeter, not going to work because the units don't cancel out. So do your conversions first. Okay. Third, once you have the proper units, then you go and plug them in and calculate. Okay. Now, some couple things to help you out when you're reading the problems. Okay. What are some terms that means equals, add, or subtract, or multiply, or divide? Okay. Well, equals, one of the terms is. Okay. 1 foot is inches. That's a term for equals. Obviously, terms like equivalent and other things like that. Add, you can say sum or plus, etc. Subtract, you might see the term minus, difference. Multiply, a key one, of. Okay, if they say something is 2/3 of 5, then that means you're taking 2/3 times 5. Okay, and product, etc. Okay, divide, per is a key one. Okay, and hopefully as you go along you'll find a couple more also that show up. Okay, now here's your review. When changing a given quantity of miles to kilometers, in other words, someone gives you a certain number of miles and they say, hey, go change it in kilometers. Which unit should go on the top of the conversion factor and which one should go on the bottom?